So hello ladies and gentlemen, welcome to another session of Introduction to Deep Learning. In this session, we will continue from where we left off. So right now we are going to implement the Perceptron algorithm again further. So let me share my screen, okay, so that we are here. So right now what I did is I have just kept the images for your references that we have already learned in the previous sessions. So as you can see, so we are actually trying to build these things only. Okay, so let me just walk you through here. So as you can see here in the Perceptron, so let me make it slightly bigger here so that you can watch it clearly. And as you can see, so Perceptron wise, so we have like kept few things which is actually done in the previous session. And then I was talking about the Z outcome. So Z outcome is actually this outcome that you can see on the diagram, and then activation function that you can see. So as per Perceptron, it was used as a step function. So we are mentioning this here. And then we will be implementing. Then similarly, fit method is for the training purpose, prediction is for the predict method. That is means predict is nothing but it's forward pass. So whatever, when the weights are getting trained, and then once it is trained, so whenever you start passing the input values here and you give an outcome, so it is nothing but it gives you it's actually a forward pass only, nothing more than that. So that's the predict method that we are going to build here. And then there is total loss. That means after passing all those data, so what is the total loss or average loss, that is we are going to calculate here. Then after that, saving of the model, that means whatever the model or the weights we have trained, we can save it by using this method. And if you want to load the method again, so you can also load the method by this method. Okay, there is a load method. And then create directory and return path is actually, let's say if you want to save a method or save a model, so you can save it in a certain directory, so it will be taken care by this method. So that's what we are going to build here in this section. So let's try to work on this one. So as you can see here, so let's try to work upon the few important things. So let's try to first of all go into the fit method itself, okay, and then we will gradually proceed further. So in the fit method, what will happen, so let's say you have got the basic stuff, that means you have got these like basic stuff ready. Okay, so now let's say after that we want to implement the fit method. So in the fit method, what we have to do is we have to pass the your, okay, we need to pass the x value, that is your, okay, just a second, I guess. Yeah. So we are actually passing the x value and then y value, that is your label, and x is your input data. Okay. And we are going to pass this in this fit method. So this will take these values. And after that, let's see what we can do. So here, let's define it. Self x is equals to x and self dot y is equals to y. So we have got these two values now. So after this, what we have to do, we have to we have to attach bias with them. So x with bias is equals to, we will be creating a concatenation operation here. So np dot c underscore, this will help us to concatenate. So we want to concatenate self x with the minus, that is np once. Okay, and then we have to provide the shape of it. So shape should be it should be equivalent to the input value that you are providing. Okay, so let's try to do this. So we are going to be length of self dot x, okay, and it's going to be your comma, and then once it's going to be a column matrix of the length of size self dot x. Okay, so we have already done this calculation in the previous classes, so we are just following the same thing here. Okay, so just is getting the matrix of x with bias. Then after that, if you want, so you can also print this status. So we can just simply say that x with bias is equals to, or you can simply a new line character we can introduce, and then we can mention is here that x with bias. Okay, now let's close this. So we are done. So we have, it will be printing the x with the bias terms. Okay, now after this, what we have to do, we have to run for the epochs. So for epoch in range, this will be equals to self dot epochs. Okay, so it will be, the data will be passed through this, and then we will be printing the like which epoch it is. So let's try to print that. So it is going to be, let's say, for epoch, and then we can mention in this form, let's say it is going to be your epoch value. So it will be printing the epochs. Okay, we can just press tab also, so it will give me suggestions here. So this will be printing the epochs at which epoch it is. Okay, then after that, what we have to do is we will be creating the, or we will be calculating the z value. Okay, so z is equals to, it's going to be self dot and this we'll be calculating with the help of the internal function that we have built, that is z outcome or z outcome, and which will take the x with bias, okay, and also it will take the self dot weights, okay. So we'll be multiplying weights with the biases, okay, actually that is x with the bias and this weights, so this will give us the z value, and then after that we will be passing this v hat is equals to, that means actually y hat is equals to, that is your predicted value is equals to self dot, and this is going to be an activation function. It will be passing through the activation function will take this z value and it will return the outcome. So now let's try to first of all build this internal of z outcome. So z outcome is actually nothing but it's going to be simply it is going to return me, and also it will take these values that we were expecting here, so we will be passing, so these values will be passed here. So let's try to put it here in this section, okay. So this will take the self x with bias, and then and after that it will try to return me the product of this, so np dot, okay, np dot, or we can simply call this, instead of calling this we can simply call them as x and w, okay, or simply weights, and this is going to be input with bias inputs, okay. So it is going to be np dot and then inputs comma weights. This will return me the product of this thing, so the weights times the inputs, okay. This will gives me the this will give me the z outcome, okay, since this input also include the biases, so it will give me wx plus b, okay. So that will be the final outcome that it will be giving, and then after that that will be passed to your z value will be passed to the activation function. So activation function will now provide me the product like predicted value. So activation function will return what? So let's try to build that. So it will be returning me the, like, whether if the term is, or if the z outcome is negative, so it will give me simply, it will give me a 0. If it is positive, so it will give me 1. So np dot where we will be utilizing, so we can use this or we can also use the if else condition, so it's up to us. So right now I'm using this np dot where function. So it says that if the z outcome that we are passing into this one, if the z outcome is, if it is greater than 0, then provide me 1, and if it is not greater than 0, then provide me 0. Okay, so this is an if else condition that we have written here in the activation function. This is nothing but a step function that we have written, okay. That is this section that we are trying to implement here. And now after this, what we will do is simply this will give me an activation function outcome, that means the predicted value or the y hat value we will be getting. So we can simply mention here also that printing the values like, so f, so we can say that predicted value after forward pass is going to be this y underscore hat. So this is what we are getting. We can keep it in the new line so that it can looks clean. And then after that we will be calculating what is left. We have to calculate the error as well. So self dot error is equals to self dot y minus y hat. So self dot y is actually, but it's actually the actual value, okay. So here we can mention that, okay, what is the error? So we can say that error as is equals to new line, and then we can mention them self dot error, okay. So this will give the, or it will print the errors, and then we can simply say that, okay, self dot weights, okay, weights is equals to, that is going to be weight update rule now. So self dot weights, that is the old weights that we have, okay, and then plus learning rate, that is self dot eta, okay, multiplied by, we have got the simply, that is np dot, okay, or we can simply use the, again, the z outcome, or we can simply say that that is still, so it's going to be simply x, that is xi, as you can see, self dot error times this, so x with bias dot transpose, and then we need to pass the self dot error. So this will give me the weight update, okay. So that is the weight up, this is weight update rule, that is w plus learning rate times error, okay, and times this x input or xi input. So this will give me the error and or the updated weight. So we can simply print these values. So print, and then we can mention that, okay, so updated weights after epoch. So which epoch? So let's mention that. So we can mention that, okay, that it is the epoch out of how many epochs. So we can also mention that self epochs. And then after that, we can simply mention that what is the weight update. So weight update is nothing but going to be, this is your self dot weights. So this will print the weight outcome. So this will give us the that is the every epochs. Okay, so it will try to give me the outcome. This, so we have got the basic setup done now. So after that, we will be in the next session. What we will do, we will simply embed this predict method, total loss, and all these things. Okay, so till then, keep on exploring, keep on reading, and stay tuned with me. Thank you for attending this one. So hello ladies and gentlemen, welcome to another session of Introduction to Deep Learning session, and we are actually working on the implementation of the Perceptron. So this is going to be the third part of it. So what we have done in the previous session, so let's get started from there onwards. Okay, so we have actually created this init method, then outcome, activation, and the fit method. So we were actually left with the predict method, total loss, and these actually create directory, return, hidden, you can say method, and then save method and load method. So once we are done with it, then we will be able to utilize this class. So from the previous one, I have actually added some few extra lines here. You can see this for the segregation purpose, so that this will segregate the every epoch, and the end of each epoch will also be segregated by these hash. So hash double hash times 10, that means it will be creating a 20 hash. So it will look like there is a separation between these prints, okay, for every epoch. So that's why I did it. Now let's try to implement the predict method. So in the predict method, what you do, you normally provide a input, which can be, let's say, let's call this as a x as of now, okay, which is going to be your input. Now after that, as you know, that we have to first of all we need to add a bias, because that's what we have to do here. That's what in the forward propagation has been done. So x with bias. So what we can do is we can simply copy paste also a few of the things, right? So here also, if you can see here, what we do is we create this x with bias. Okay, so we can keep this here as it is. Only thing that we have to change is we need to remove this. Instead of self.x, I will write x, because it is just associated with the x value that you are passing here. Okay, or otherwise, if you feel that this sequence is slightly confusing, so what we can do, we can also name it something else. Let's call this as some sort of, you can say, let's say test input. Okay, or you can say inputs for prediction. So you can name it anything. So let's keep it very simple. So I think you will be able to understand these things. So x is nothing but here, it is actually the input that you will be providing for prediction purpose. So now we have created x with biases. Okay, so after that, we have to do what? We have to calculate the z value. Okay, so z value will be taking the what? This is z is going to take your like input value. Okay, so we can use here what? We can simply use our self underscore z outcome here simply. Okay, so it will take the x with bias that we have created here, x with bias. Also it will take the updated weights, because we are doing the prediction. So weights, these self dot weights are nothing but the train weights that we have. So this will give the z outcome, and after that, what we have to do, we will simply call for the return method. Okay, so return will do what? Return the self dot pass these values to the activation function. Okay, so the z value that you have calculated will be passed to the activation function. So this is all about your prediction part. So after this prediction, what you have to do is, let's say you want to calculate the loss. So obviously, so for the loss calculation, what you have to do, so you see, we have to simply say total underscore loss is equals to, it will take sum of the np dot sum of self dot error that we have calculated while training. So that's what we are trying to calculate here. So we will simply print that, okay, f, so total loss, okay, is equals to, you can simply mention total loss that we have calculated here. Okay, so this will give the total loss here, and then we can also segregate these steps. So we can use backward slash n as a new line character for each of them. And also, if you want, we can return this loss as well. Let's say if you want to utilize it somewhere, so you can just have this return method as well here. Now for that, what we have to do is, let's try to save the your like whatever model you have created, we will be saving it. So in order to save that model, what we have to do is, first of all, we need few things. So what we need is where you want to save. So we need to provide a file name here. Okay, so let's provide file name, And also we need to specify that model directory where, let's say if you have not created or created a model directory where you want to save these models that you have created right now. Okay, so we will be using this model directory path, okay, where we will be storing these models inside that. So these are the two things that we need. Now, since I have already passed the default value as none, so let's say, so we can write a condition for that. Let's say if model underscore directory is not none. Okay, that means if you have provided these things, so in that case, what we have to do is we will call model file path where we want to store. Model file path is equals to going to be self dot underscore create directory none. So we will be utilizing that hidden function. So it will take the model directory as it is and file name. So based on this, it will first of all try to, based on this model directory path, it will try to create a folder, and then it will attach the with the, and then it will create a path for this one, okay, with model directory and file name, and it will return this function is that job. So we can simply mention these things here. So model directory and file name is, it is going to take these two values, and it will first of all, it will take the, it will make the directory first of all. So make directories, okay, and then it will take the model directory and the, it will first of all, it will say that exist okay is equals to true, so that it does not give me error if it is already existing. So next thing is that return the path that you are going to create. So os.path.join, and it will take the model directory and also the file name. So this will, so first of all, before we write the model, we need to have the directory, parent directory. So that's what it is doing here. It is creating a directory here, and then we are saving the file name inside that, or actually the file which we have created. So that will be saving it here. So once we are done with this model or file path there, then after that we can simply call this job lib to store them as a binary dump. Okay, and then what we want to save, we want to save the self. That means whatever has been calculated, these self values actually going to be saved as a binary, and that's what we are going to use. Okay, we are going to use the weights and all, so that's what we are going to use. So we are going to save our self, okay, then model directory or model file path, we will be passing it here. So that where we want to save this binary, we want to save it at model file path. Next is about the else statement. So else statement is now model file path is equals to, okay, again self dot create return, and let's say you did not give any file name. So in that case, we will create a file name. We will actually model directory. So we will create, in that case, we will be creating the model directory for you. So model directory will be created, file name will be passed, and rest of the things will remain same. So joblib dot dump the self value, and then that is self for return. That means self all the like these models like self dot x, self dot errors, and everything will be saved here, okay, by using this joblib dot dump in this model file path. So this will actually save our model. Now let's say if you want to load the model. So for the loading a model, what you need, you simply need a file path that where the data is located or where the model is located. So it will take this and it will return the, it will read it by joblib.load, and it will take the file path. Okay, so this will return me the, it will, this will simply return the loaded you can say model that we have created. So this creates our, or this completes our Perceptron class that we have built. Okay, now in the next session, what we will do, we will try to utilize this. Hopefully you might like encounter some errors, so we will be resolving on the way, although it seems correct till now. Okay, but sometimes it happens that we may miss something, so it's okay. That is a past part of the process. Okay, so till then, keep on exploring, keep on reading, and stay tuned with me. Thank you. So hello ladies and gentlemen, welcome to another session of Introduction to Deep Learning. In this section, we will continue from where we have left off. So we were actually working on the Perceptron algorithm implementation using Python. So let's get started. So as you can recall from the previous session, you can see that we have implemented the Perceptron class here. Okay, so now let's get started. Let's try to utilize it. Let's see how it works. Okay. So now in this section, what we will do is, first of all, let's try to define a data set. So we are actually working on the data set that is AND gate. Okay, so AND gate will be actually, we will be trying to make our perceptron model learn the AND gate. Okay, so we'll try to do that. So first of all, we need to define that, okay, what is our x1? So x1 is going to be a list. Okay, so it is going to be a 0 comma 0 comma 1 comma 1, and then we have to specify the x2. Okay, x2 is equals to, it's going to be 0 comma 1 0 comma 1. Okay, and then we have to specify the label. So label data we are going to have is equals to, it's going to be, so since we are working for AND gate, so AND gate is actually, it only gives one when you have all both the values are high. So that's the outcome. Otherwise it will provide you a zero value. Okay, so this is our AND gate. Now let's try to convert them into pandas data frame. So it is going to be pd dot data frame. Okay, and we will pass this dictionary directly. So this will create a data frame. So let's try to check the data frame. So as you can see, x1, x2, y, and this is going to be your AND gate data set. Okay, so this is your AND gate data set. And now let's try to do what? Let's try to, first of all, or before that, I think we should do one thing. So let's try to make it, let's give it a specific name. So let's call this df and this. So this will be data frame for AND gate. Okay, so this is done. Now let's try to first of all segregate these so that we can pass it to the our model. Okay, so for that, what we have to do, we can define one function which will simply do a preparation for us, or preparation for the data frame. So what will be this function? So let's try to define this function just above this one cell. Okay, so we will call this function or a helper function as prepare data. Okay, so prepare data will just simply take the data frame, what it will do, and then it will, first of all, it will try to give you like df, it will drop the column. Okay, it will drop the column, that is your label column, and axis, since it's a label, so axis is equals to 1, and then it will, after dropping, so it will provide a x value, that is your features, and then y will be simply is equals to df, and then that is your target column. So now after this, it will try to return me x and y. Okay, so to make it generic, more generic, so what we can do is we can also provide here one more axis, or one more you can say target, and let's call this as a target column. Okay, so target column, in our case it is y by default. Okay, so let's say if you try to provide something else, so we can make it more generic here, so we can try to provide target column as something else. Okay, so in this case we can replace it with this one and this thing. So what it will do, it will simply provide me an label which is y and the features out of the your data frame. So this will do the preparation of the data. Okay, so now let's try to utilize our Perceptron class. So first of all, what we have to do is we have to get the data. The data, we have to prepare the data. So prepare data, and then we will be passing the data frame. By default, since it is taking y as a target column, so we will leave as it is. Okay, and we will provide df and as a data frame. So this will give me x and y. Now let's try to define the learning rate. So learning rate we are trying to use is, let's say 0.3, okay, or 0.1 actually, which lies between 0 and 1. Okay, so this will be varying between 0 and 1, and then after that we have to specify the epochs. So how many epochs we want to run. So epochs is equals to, let's call this as, let's say 10. Okay, so 10 number of epochs we are going to create, and let's try to define model. And so this is going to be Perceptron, okay, class, and then we need to provide the ETA. So ETA is equals to that we have defined, and apart from that we have epochs, so we can also define the epochs, which is going to be epochs that we have defined. Okay, so this will now create the model object, and then after that we can simply call model.fit. So this will be model and dot fit. Okay, we'll just call fit the fit method on what, on the x and y. So we will be passing these things, and then after that we will be creating a model dot, also we will be calculating at the end, that is model dot total loss. Okay, so we can check the total loss at the end. And why I'm using underscore, because this is a dummy variable, that means we are not going to use this, so we are just calling it underscore. Otherwise you can skip this part as well, so it's not in harm. It will simply return the total loss because we have already returned a total loss here in this case. So now let's try to run this. Hopefully everything seems fine. Let's try to run this. So it takes like initial weights before training. So it says a type error. One takes person number, but three were given. So let's try to understand that what happened here. Okay. So most of the time, this may be a possibility that you might come across this kind of issue. Okay. So it seems like we have not yet started. You can see from here, actually we have defined from the last. So what we can do is we can simply restart and run also. Let's try to run everything from the beginning so that it can take everything from the beginning itself. Otherwise what happened that sometimes, let's say if I have defined in this cell, and what will happen that if I have not run the cell again after, let's say, editing this cell, so it will take the previous version, okay, or the previous values. So that's why it was giving us an error. But here if you see, so it has started printing the outcomes. So what you can do, you can see that initial weights before training, it was very low weights. Okay, it was nearly zero. And then after that, we can see that x with the bias term here. Okay, so x with the bias is nothing but it's the same, that is 0 0 0 1 1 0, and we have appended it with, or you can say concatenated with your 1, that is your bias values. And then for the epoch 0, we have rated value for the forward pass is going to be 001. So in the first pass itself, it has given us a 0 error. Okay, so you don't have to pass for the multiple errors actually, but still we can just proceed further. So you can see that luckily what we have got is actually we have got error in the first chance itself is 0. Okay, and you can see that since error is 0, you will not see any weight update in any of the cases. Okay, so this was actually a luck, pure luck. So what we can do is let's try to rerun it. So hopefully we will see the differences here. Okay, since it's a random one, so we can see the differences. At the end it is 0. Let's try to see this. So it is actually designed to give us a 0. Yeah, here you can see now from here in this case it was not like that. So in this case you can see the predicted value in the first forward pass was actually different, so there was an error. Okay, and after that we has in the second epoch you can see that there is one error was there. Okay, then there was third epoch, again there was an error. In the, you can say, fourth epoch, you can see again there was an error, and so on. So in the fourth, or you can say fifth epoch, you will see that it was a 0 error. So after that you will see that it will be consistent, the weights will be consistent, it will getting utilized. So you can see that now it is, I can say, at the end. So we don't have to train actually to the 10th epoch. So as you can see here, it was actually giving us total loss at the 0. But right now you can see that it is 9 out of 10 it is running. So what we can do is we can simply edit these things. Okay, so what we are doing is actually we are just printing the exact epoch. So we can simply say +1 here because epochs starts with 0. Okay, if I give it range to 10, so it will start with 0 to 9. So let's try to run this again, and I think then we will be able to get the exact look. Okay, so at the end you can see 10 out of 10. So this is now absolutely fine. So this time also let's see that, okay, whether you are able to get some errors or not. Yes, there was few errors and it was able to solve properly. So that means our perceptron algorithm is working fine. So in the next session, what we will do, we will try to explore on different other types of gate like OR gate, XOR gate, and we will try to see that what kind of outcome we get. Okay, and also we will try to plot these outcomes to verify these things graphically. So till then, keep on exploring, keep on learning, and stay tuned with me. Thank you. So hello ladies and gentlemen, welcome to another session of Introduction to Deep Learning. And in this session, what we will do is we will simply explore further in the perceptron algorithm. So in the last session, what we did is we have actually created, and you can say we have already created a perceptron class. We have also checked it for the AND gate. And so in this one, we will try to explore for the OR gate as well as the OR gate. So let's see that how it works. Okay, so let's get back to work. And here you can see that we have already created an AND gate for you. So now let's try to copy this, and we will just try to explore for this is for the OR gate. So let's call this as OR gate. So as you know that OR gate actually gives you that, okay, if both the either of the values are high, so it will simply give you a it will simply provide us a high value. Okay, so let's try to look into this data set. So as you can see, the data set is actually, let's say that either of them is I, x1 x2, so it will provide you y as an output. So this is the data set for OR gate. Okay, now let's try to work on this part. So what we have to do is we can simply copy paste this, and instead of this we will be passing our OR gate. Okay, so let's call this OR And here let's call this as model R. Okay, so this will create actually the, this will actually just try to calculate the OR gate as well. Now let's try to run this. So as you can see that it is able to like get the errors in this one. So it is actually getting the errors and so on. See if I scroll over, so you will find out that okay, after some time it will start giving you a zero error in every case. So at the end you will find out that okay, total loss is exactly equals to zero. So that means we were able to train this model as well, and it was giving me the better results. Similarly, what we can do is we can also explore for XOR gate. Let's try to experiment with the XOR gate. So XOR, it actually, it's nothing but an exclusive OR. That means if either of them is high, then only it will provide you one. But if both of them is high or both of them are low, so it will provide you a zero. So let's try to explore the XOR gate as well. Okay, so this is called as exclusive OR, and we can simply call for X here, and then X here, and it will provide you a zero in this case. Now let's try to run this. So it will be, this is the dataset for XOR gate. And now let's try to run our test here. So we will be simply creating a model which is for the XOR gate. And this is going to be XOR, XOR. Okay. So this is, let's try to see the results. So as you can see, if I just scroll over, so let's see that whether it was able to reach to the zero or not. So you can see that it was not able to reach to the minus, and that is to zero. So the error was actually still there. Now let's try to run it again. So if you just see again, the loss is exactly is equals to 2. If I run it again, so you will find out that okay, the loss is not yet decreasing. So what could be the reason behind this? So we will be exploring this. And the main reason, as I can tell you from the theoretical understanding, which we have already explored in the previous sessions. So it is that like the perceptron algorithm is actually now, it's a linear classifier. It works for the linearly separable data set, not for the non-linear data set. And to experiment this, we need to actually, or to prove this, we need to actually plot the graphs of these data sets that we have created. So for that, we will be exploring them in the next section. But before that, let's try to explore a few more things here. So as you can see in this section, the Perceptron class that we have implemented, you can see also you have to find that, okay, there is one more way, that is like if you want to save the model or load the model. Okay, so that is also present. So let's try to experiment with that. So let's say you have created this AND gate. Okay, now you want to save him. So what you have to do, simply call model and then AND. Okay, and then you need to provide few information here. So as you can see by the definition here, okay, if I see the definition, so it expects me the file name or model directory as well. So if I try to get the model name here, so model name, okay, so I try, okay, so it has to be model name model, and then dot save method we need to call for. And then if we specify here, so file name is equals to, since it's an AND model, so AND, we can say that dot model if you want, or since it's a pickle file, so you can also say pkl as well. So it's up to you. The extension doesn't matter here because it's going to be binary file whether we write any extension here, so it doesn't matter. Now after this, we can specify that okay, which is going to be my model directory, that we can specify. But let's say if we do not, so what it will do, it will simply create a model directory and it will save it. Okay, let's try to run this. So you can see that it has actually ran successfully. Now let's try to check it in the home page. Okay, so if we check at the home page, so you will see there is a model, like I said, directory is now created. So and.model is now present here. So what we can do is, apart from this, now let's try to see if we can reload this model and understand that okay, whether we can recall that, you can say whether we can predict the method or not. Okay, so let's try to reload and okay, and we can simply easily call it as, let's say, uh, we can call for the perceptron algorithm, okay, perceptron. And now in this case, we have to provide, as you can see in this definition, so if you can recall, so by default it is none. Okay, that epochs are none. If you do not provide anything, that means it will treat it as it will treat that it is now not training. But if you provide that, that means it is training. So that's what we have written in this conditional statement. So right now I am just initiating it, and then after that we can simply call for load method. So we are actually initiating, or you can say again reinitializing the you can say that we are reinitializing the perceptron class, but in this time it is not training. So we can simply call for load method. Okay, and in this load method we can also call the path of this. Okay, so let's call it as file path. File path is equals to, it is present in the model and model directory, and the name of this is and model. Okay, so if I try to do this, so reload and, so let's call for this one. So you can see that it is now loaded. Now if I try to give me the, if you try to prevent, or you can say if you try to predict the method based on this one, so we can simply call for reload, and we can also call for the predict method. Okay, and here we can simply specify x value is equals to, we need to provide it as, let's say we can, it has to be a two-dimensional matrix because that's how it is arranged, the data set is arranged. So if I provide 1 0, it should provide me the output as 0. Okay, so it is able to give me 0 because both of them are not 1. That means one of them is low and one of them is high. So if I provide both of them high, so it provides me 1. That means I was able to successfully reload the model, and also I was able to predict the model as well. Okay, that means this is how it works. Now let's try to do it for the this OR model as well. So we can simply copy, I can simply save the model for the, you can say for the OR model as well. So let's try to do it for the OR model here, since we have already created. So we can simply save it here. So model OR dot save, and let's call for OR model. So if I try to run this, and this time what we can do is we can, let's try to provide the directory structure or directory name, model directory. Let's call it as a model or, okay, just for the simplicity. Now that means just to explain you that, okay, whether this thing works or not. So if I try to do this, we can observe here that, okay, this model or is actually created, this folder is created. Now inside that or.model is now saved. So in this way we can also reload this model as well. So it's our choice. So we can give the full path of the model from where we want to reload it, and that's how you can save and reload the model. So this is the method that we have created for the, so as you can see in the Perceptron class, we have actually used all the methods that was already there. Now after this, what we will do is we will simply try to plot all these graphs for them for the prediction of these output, and then we will see that what kind of you can see how we will try to explain that why perceptron is actually applicable on the linearly separable data set or linear data set, not on the non-linear data. So that is actually a weak point, or you can say a disadvantage of perceptron algorithm, or you can say one perceptron. So we will try to explore that in the next session. Till then, keep on learning, keep on exploring, and stay tuned with me. Thank you for attending this one. So hello ladies and welcome to another session of Introduction to Deep Learning. So in the last session, what we did is we have already implemented the perceptron algorithm. We have trained the model, we have saved it, we have loaded it to the model. But as in this session, what we will do is we will try to explore further. We will try to justify that why it fails, why perceptron fails for the XOR gate, why it survives for, or why it gives the perfect results for AND and OR gate. Okay, so the reason we will try to explore, and actually we also know the reason theoretically that perceptron is actually works for the linear data set or linearly separable data set, we can say. So it only works for such kind of data set. So that is the drawback of perceptron. So we will try to justify this statement by doing certain experiments, by plotting the graphs. So let me show you one of the I can say this graphs here. Okay, so right now I'm doing it by sketching it, and I will write after that I will try to code it out as well. So the objective here is, as you can see on the screen, so let me just explain it briefly. So this is x1 axis and this is your x2 axis, okay, which is the vertical axis, and it is actually pointing out these data set that is present here. So x1 and x2 we have got, and y is the outcome. So as you can see, since it is an AND data, so AND data is actually, it gives you 1 only when both the values are high. So then only it will give you 1. And as you can see, observe here, so y is just giving us 0 or 1. So that means the classes are 0 or 1. Now the 0 classes are actually represented as a hollow circle, and the 1 class is represented as a like it's a dark circle. Okay, so as you can see on the screen, so what I did is I have marked it, so you can see at this location this is 1, this is 2, and so on, -1 and -1 at the end, and here it is 1 and here it is also 2. So if I try to plot all this graph 0 0 0 1 1 0 1 1, so I have already named them as A B C D. So you can see that A will be 0 0, B 0 1 1 0, and so on 1 1. So 1 1 is represented as a dark circle, so that means that it is actually giving us the outcome as 1 as a class. So if I try to classify this, so what can be, since it's a linearly classifier, so if it is linear, so we have to draw a line here. So a line will be actually be separating these two classes, as you can see. So as you can see, there is multiple space here in between this, okay, and here as well. That means there can be a multiple line possible to draw, okay, that will be able to separate these two classes. Okay, so in order to do this, okay, let me just make it slightly larger here. So let's keep it from here till here. Okay, so if I try to do this, if I try to like first of all, we, instead of creating a line, so let's say we already have a model. Okay, so if I try to pass a model value, okay, let's say if I try to take a value from here, let's say at this location, whatever it may be the value, if I try to pass this value, so it will definitely give me either it is 0 or 1. That is the one thing that we will get. So let's say let's assign 0 as a, let's say assign for 0 class, let's say let's assign this as a this color, this is your 0 color, and for the 1 it is representing by a green color. So what will happen, so this will give me a, if I try to predict this, so it will, we can just show it as a blue color, okay, sky blue color. Similarly, if we try to keep on pointing, so in this way what will happen, so it will try to keep on predicting, and so on, it will try to, based on our algorithm that we have already trained, or the model that we have already trained, it will try to fill all these values here, okay, which belongs to a 0 class. Okay, these all values, this all values will be filled here. Okay, so similarly, if I try to find out the value here, or if I try to figure out that, okay, which class it belongs, so it will try to give me a value which is green. Okay, that means it belongs to a one class. Similarly, if I try to plot for every point here which is located here, so this you will find out that, okay, this will be creating a green color here for every location here in this section. So it will try to provide me a green color here. Okay, this will try to fill with the green color. So let's slightly make it larger and try to fill this up as quick as possible. So you can see that, okay, this is going to give us a green color here, okay, for every such location. Similarly, we can make it for the blue one. Let's make it larger here. So you will find out that, okay, it is trying to fill up all this area with the blue color. So that's what our objective is, that we will try to find out what will be each point representing. Okay, so we will try to fill this up area. So if I do this, so it will appear that there is a certain line which is trying to separate these two things. Okay, so separate these two classes. So let's try to build this by writing a code. Let's try to justify this. Okay, so I hope you got the understanding. So let's try to justify this by writing some code. So let me minimize this and let's get back to our Jupyter notebook. So we will define a function which is called as save plot. Okay, define. We will call for save underscore plot, which will try to first of all take the data frame, and it will also try to take the file name because we want to save our file as well. Okay, and also it will take the model, so what model we are trying to plot. Okay, so that will, it will take. So now let's try to keep this model here, and let's try to define the file name as a default, some default value. So let's say the file name is equal to some called as plot.png. Okay, let's say we are trying to save it as this one. This is the default that we have given, and this will try to save the plot. That will be the agenda for this one. So we will try to implement this function. Okay, so now let's try to work on this one. So the first thing that you should do is whenever you get the data, you will be first of all implementing, what we have to do is we will be segregating them. So x comma y is equals to, we will call for the prepare. We already know that we prepare data is already available, so it will take the data frame, it will represent, it will try to give us a x and y value. Then after that we can create an internal function here, so which will create the base plot. That means the representation of the x and y, these coordinates that we have got, okay, x1 and x2 coordinates. And then the second function will do a decision function. It will prompt a decision function, okay, decision region, which is represented as, I can recall, so as a blue, okay, and green. So that's what it is trying to represent here, x and y model. And then after that, what we will do is, since once we have created these two, like created the base plot and the plot that we have got, so next after that we will define a plot directory, let's say, where we are going to save everything. So let's call this as plots, okay. And now it's better, we can simply specify this as also an argument, okay. So this will be much better. So we can define this as an argument here, that this is going to be a default plot, okay, plot directory. So what will happen that after this, we can simply call for os.make directory. And if this plot directory is not created, so we will simply create this plot directory, and it will say exists okay is equals to true. So if it is already present, so it will override this. And then after that, we will try to find out the plot path, okay. So where we want to save it. So let's try to clear this. Let's try to create it. So os.path.join, and we will simply take the model directory, model, or you can see, sorry, not model directory, it's going to be plot directory and the file name, okay, where we, so this will create a total path to this function, okay. So the path to the plot that we have created. And then after that, we will simply save it, save the plot by calling for plt dot save figure. So save figure, and it will take the plot path as a final path where we're going to save the plots. So this is going to be our function, but we are yet to implement this create base plot first of all. So what we have to do is we will simply define an internal function here. So let's call this function, internal function, as create plot. This will be create base plot. That will be taking the data frame, and it will be creating the plot. So let's call this, let's pass this as of now, okay. And then after that, we will be creating one more, you can say plot decision regions, and it will take the x and y, that is features and labels, and then the model that we are going to use it for plotting it. This will, let's call it as a pass. So this is the function that we are need to implement these things. So we will be implementing this internal function in the next session. Till then, keep on exploring, keep on learning, and thank you for attending this one. So see you in the next session. Thank you. So hello ladies and gentlemen, welcome to another session of Introduction to Deep Learning. So let's continue from where we left off in the last session. So in the last session, we were actually creating the save plot function, and we have just created the skeleton of it. Internal functions are still left to be built. Okay, so let's try to work on that in this particular session, and let's do some observation about whatever model that we have created till now. So we will be working on that. We will try to explore and we will try to justify them. Okay, so why the certain results are coming in. So let's try to observe it here. So if I just open up here my Jupyter notebooks, as you can see, this is what we have done in the last session. So let's try to first of all open these, or just create these plots. Okay, so first thing is that let's try to define it. So we have got this internal function create base plot. So it will be actually creating a scatter plot out of the data that is given into this, to this particular you can say data frame. Okay, so df data frame itself has a plot method. Okay, so we will try to utilize that here in this case, and we will specify the kind here. The kind is going to be scatter plot. Okay, and we can also specify the x values. X is going to be x1, since that is the, you can say, your that is the first column. Okay, and then y is equals to, here it is going to be actually x1, x2. Okay, so this is going to be your x2, and then the whatever is the c value, that is the color value, where c is equals to, it is going to be y. So that's what we have till now. And then after that, we have to also specify the diameter of these circles. So it is going to be 100 as of now. We are just creating it, making it large. And color map we are choosing here is as a cool warm. Okay, so we are just keeping this as a color map. Now after that, we can simply plot the horizontal axis and the vertical axis. So ax h line. Okay, and then we can specify that where we want to. So we can just, we are trying to draw a, you can say y is equals to 0. That is nothing but it is going to be a horizontal line. Okay, so color is equals to, we are specifying here as color is black. Okay, and then we have the line style. Line style is equals to, it's going to be dash, okay, hyphens, and we have to specifying the line width as well. So line width is, we are keeping it to the minimum, so we are just keeping it as 1. So this is about the your x-axis that we are trying to build, or horizontal line. Now let's try to create a vertical line as well. So in the vertical line, we are just going to check this x is equal to 0, and also we will be calling it as a v line, ax v line. So this will create the horizontal and vertical axis for us, and then we will simply plot these figure. So figure is equals to plt dot and gcf. Okay, let's get current get current figure, and then after that we have to simply set the size of it. So set, okay, and size inches. Okay, so it is going to be 10 comma 8. We are trying to keep it. Okay, 10 comma 8 is the size that we are keeping it. Now after that we have to, since this will create just a scatter plot, but we need to also plot the decision boundary or decision regions. So let's try to create that. So let's take some color list. Okay, let's tuple of colors. So it's not necessary that we can take it, we can take it any size. Okay, but we can just let's say since we are using just 2 only, so we can just use light green here. And okay, so these are going to be the colors, and cmap is equals to actually listed colors we have already used, and in this one we need to pass these colors. Okay, colors that we have defined here. Okay, now after that we have to simply call for x is equals to x dot values, so that we can get the array values from them. Okay, these are the values that we are going to, so get as well, it's called as an array. And then after that we have to be specifying the x1 is equals to, which is going to x, and it will take all the rows but 0th column. And similarly we will have x2 as well, which is going to be all the rows but first column, so we'll call it as x2. Now after that, as you can recall from the pic, so we have to we have to extend the area so that we can plot it very well, and it should look like that. So as you can see here also, I have extended it from 1 to 2 actually, and also here, so that we will create a graph like this. So we need to do that. For that we have to just get the minimum of x1 and maximum of it, and then we will, in the minimum we will just subtract by 1, and in the maximum we will just add it by 1. So x1 underscore min and x1 underscore max. Okay, so how it is going to be, so let's call it as, so x1 dot min, then subtracted by 1, and then x1 dot max, and then what you have to do, add 1 to it. Similarly we will do it for your x2 as well. Okay, so replace it with this with x2, x2 max, x2 min, and x2 max. So this will get us the max and min value. Now we have to find out the mesh grid. That means each points which will create those kind of like, which will create this grid, or you can say decision boundary, or decision, you can say regions. So first of all we need to get the mesh grid here. So mesh grid will take the two range functions. So np dot range, that means x range we have to get. So x1 underscore min, okay, and it will lie between this and x1 underscore max comma resolution. So there's something called the resolution. That means how, at what like range we want to keep it. So resolution, if you keep it as low as possible, so it will be like the graph will look more continuous. So we will be defining this extra term that is called as resolution. Okay, resolution is equals to, which is going to be 0.02. So this will actually be creating a, you can say this will be creating this mesh grid. Okay, I will just explain mesh grid as well. So np dot range, let's say actually it's going to be a range. Similarly a range here, Okay, and it's going to be x1, actually x2 underscore min, comma x2 underscore max, comma resolution. So this will create the mesh grid for us. Now let's try to understand what is mesh grid here. So I think we can also recall from the previous pick. So let's say if I start from the top left corner, that is from minimum to both, or bottom left. So it is going to be, this is going to be what? This is going to be the minimum point. So this is going to be the minimum point, which is actually resembling this area, this part, and this part. Okay, so this is going to be your minimum points, this point actually here. So from here, what we will do, we will take the resolution of you can say 0.02, and this will create another point, and so on. It will keep on creating the another point. So once we reach till here, and then what we will do, we will start from just 5.02 resolution and so on. So we'll try to gather all the information about these points. So we will get also at this location we are going to get as x1 min and x2 min. Okay, so this is going to be my coordinate for this one, and similarly you will be getting all the coordinates. So that's what we are trying to get in the mesh grid. Okay, so that's what we are trying to get here in the mesh grid. So xx1 and xx2 is going to be actually a matrix of this shape, this like x1 and x1 max. Okay, so then based on this resolution, what will be the length of it? So based on that, it's trying to create a square matrix, so it will trying to give those values. So this is x1 and x2 that we have got. Now let's try to get the prediction, okay, out of these. So at every point we are going to get the prediction. So let's try to call the classifier that we have, and then on that we will call the predict method, okay, which will take the value as np array. Okay, we'll take the value of np array. Now these values are actually in the shape of matrix. Okay, so we need to convert them into, we need to go for xx1 dot ravel. Okay, so ravel will actually simply flatten these into a single array. Similarly, xx2 dot and then ravel. This will again flatten the array. And now we will take the transpose of it. So that we will get a column matrix where xx1, xx2, xx1, xx2, and so on, it will be given. So it will be kind of, you can say, input values. You can think of as an input value which will be passing to this, and this will give the prediction. Now this y hat will also be later on, it is going to give you a kind of, you can say, list. We need to also reshape them, or you can say array, np array, we will be reshaping them of any one of the shape, xx1 dot shape or xx2 dot shape. So we are just taking this. So this will give us y hat in a matrix format. So now after that we will plot the contour function. So let's try to do that. So plt dot contour function, and what it will do, it will take the xx1, it will take the xx2, and it will take the face value as these y underscore hat. Okay, and this will decide the color of it. So alpha is equals to, we are keeping it as equals to, that is going to be transparency. So we are keeping it transparency as 30%, and then after that we are providing the c map is equals to c map. Okay, so this is going to be the color map. Then we can also do the limitation here. So yx limit can specify, so it's going to be xx1 dot min is going to be x limit, and xx1 dot max is going to be your, this is going to be your x limit. Similarly, we will be having y limit as well. So y limit will be xx2 min and xx2 max, and we are going to have a y limit now. So after this, we will simply call for the plt.plot method. We will plot the graph as well in the current, you can say, in the same you can say Jupyter notebook itself. So let's try to run this. Okay, so this function is now ready. Now let's try to utilize this function. So what we need is, we simply need save plot. Okay, let's call the save plot method here, and what it expects, let's try to plot that. So df, this is what it is trying to give. Okay, this is the expectation. So right now we are not plotting the plot directory, we are keeping it as it is. Okay, instead of plot.png, we will simply call for the, let's try to see that which model is ready last. So we had the XOR, we have OR as well. Okay, so let's try to utilize this dfr. Okay, so dfr we are going to use, and model or we are trying to use here, and let's call the name as r.png. So if I try to plot this, you can see here it is trying to create a line or a boundary condition here, which is trying to segregate this class and these three classes. It appears that okay, this is going to be passing through the entirely, or it is overlapping, but since we have actually increased the radius of this graph, so that radius of this particular point, that's why it is looking like that it is passing through the line, but it is not. Okay, it is actually trying to segregate these things. So this has actually created what, a kind of similar graph that we have already built here. So here what we did is, in this case, so blue on the left and green on the right. So we have just did that. So it's similar kind of, it's kind of light blue here and the green here, and it is trying to do the same thing that we were looking for. So it is actually trying to create a decision boundary here. It's a kind of x and y. This separation is there. So this is for the OR model. Let's try to do it for the AND model as well. So and going to be and.png, it is going to save, and this is going to be your AND model. So let's try to run this. So for AND model also, you can see that it is trying to give this kind of graph. See, it is trying to again segregate these three classes, which are actually nothing but one, or actually zero, and this is only the one, which is the red one. So this is actually trying to segregate these things. Now let's try to observe for it for the your XOR, exclusive OR case. And then also, instead of AND, we can call for XOR. So if I try to run this, so you can see this, it will never show me the convergence, or it will never try to show me a boundary here. The reason for this is actually because, as you can see, that there are two lines here, right? There are two like these are the, this is actually 1 and 1, and this is the blue ones are actually, this is 0. So if I try to even draw a single line, so it will not be able to bifurcate these into perfect classes. So there will definitely be error whether you try to draw a line in this direction or here. So it is always going to be an issue. So because this is actually not linearly separable, so what we can do is we can either draw an ellipse which will segregate these 2 points, or we can also draw, you can say, a kind of hyperbola, so which will segregate this and that, this particular graph. So that is also a possibility. So these are the few things that we need to take care. So it's actually not a linearly separable or a linearly separable data. That's why this is where the perceptron algorithm fails. So this is the proof for it also, that okay, it will not be able to converge with the simple perceptron class. So for that, the solution can be either you have to implement the multi-layer perceptron, or you can say artificial neural network that we are going to study in near future. So, or in the upcoming classes. So that's all. I think this is all about the perceptron that we have studied. So we have also learned the theory before this, and then after that we have just done the implementation of it, and we have also got the proof that why it tries to fail. Okay, so we have also got the justification with the help of this particular data set. So that's all for this perceptron lecture. So thank you all for attending this one, and I will certainly say that keep on reading, keep on exploring. Stay tuned with me. Thank you.